Okay, let's start. Thanks for joining. This is a total beginner class. I hope you are aware of that. So if you know stuff about AI already, if you know what RAG is and all this stuff in AI, it's not for you. Change the class. Now it's your chance. My goal is to give you a general understanding, a 30,000-foot view of AI, what I learned for 1.5 years now. And there are lots of slides, courtesy of Conor McDonald. He shared some slides with me. And so my intention is to give you a basic understanding what AI is, that you're not afraid anymore, and you understand what you may be doing already for quite some time. And so therefore, because we have a lot of slides, please put the questions at the end. And the best thing is at the party. I hope everybody is coming to the party. It's the whole point of a conference, joining the party, right? It makes no sense. Everything else, the content you get online or next year, you can generate it through AI, your personal presentation. That's true. So the most important thing is to meet people and for life and work with them together. So. Okay, let's start. My name, Jung Schuster. People know me probably through different activities. I would call myself a UX designer. I made a presentation 2, 3 years ago at this conference, which you find over here. If you can download it. Same thing will be with this presentation, or it's on my Twitter account pinned. So a little bit about my person. I'm doing 22 years Apex. Mark already mentioned it. I was his first customer. I was still at Oracle. And I'm the founder of apex.world. And I also did this Apex podcast for 7 years. So we have a new version there now with a beautiful AI assistant. We have all the plugins there, 400-ish plus plugins. We have a huge Slack community with almost 5,000 people, very vibrant community, ideas. You get the ideas over here. You can see in the forums question and everything. Can somebody close the door, please? Thank you. Just check it out. We have almost 9,500-ish members already. But you don't have to be a member. You can just use it. And I also did the podcast for 7 years. I ended it when Joe was gone, and yeah, but still valuable content in there if you are interested in the history of Apex. I'm also the guy with the Apex stickers. I still have Apex stickers. Get it after this presentation. This will probably be my last conference, so I give everything away. This is your chance to get one. The cool ones, the original ones, right? Um, like I said, I'm a UX designer. And it's not just for designing apps. I'm also do presentation training, slide training, blog posts. I did all the things I worked for Joe for his presentation, for example, or product or service or your whole company, right? Um, so I can design a conference. So how make you a conference much more successful with the little tweaks? But it's a very unthankful job because people say, oh yeah, it's a great idea. But when it comes down to actually tell the people what you can change, you won't like it. So my favorite saying is, the truth will set you free. But first it will piss you off. Ask Dimitri. He has some experience with that. But you can change a lot with small changes in if you design the everything you have focused on the customer and the customer only. And I'm also calling me an AI architect. I'm not coding anymore, but I have this view following AI for quite some time now. I'm part of the university and doing workshops, couple of workshops a week, and I know the right people, like always. And so whenever you consider something doing in AI, let me know. I can give you a strategy because everything is so going so crazy fast, and you can put a lot of money and effort into a direction which is obsolete in a month. And I also can hook up with you with the right people. Okay, today, what is AI? First, we start with general terms like vectors, LLMs, large language model, generative AI. Then I show you some tools and example with apex.world. And at the end, I show you what are agents. So let's start. What are vectors? You probably know this page, this slide from Oracle presentations, and I like it very much because once you have understood vectors, everything you understand AI. Right? So let's assume you have some object, in this case, a house, and you can categorize this house in different sections, like, oh, what type of roof does it have? It looks like more like a Chinese version of a roof. And if you would have a select list, you would say Chinese roof, Chinese yeah, form of a roof, right? But you wouldn't, but you, this is just a display value. You wouldn't store the display value, right? You would store an ID. And the ID of Chinese roof is 33. And the next thing, the decoration is, yeah, it's dark oak wood. It looks like dark oak wood. And you store the ID of the select list and say it's 42. And then number of stories, it's 2 or 3. And the ID of that is 16. And if you have the certain sequence of that and you store everything in one column, you still know if you have first select this is 33, what was the first one? Yeah, it was the type of the roof and the decoration. So you can store everything like that in a database. And just imagine that like a select list with ID and display value, but you just store the ID. And you can do this with everything, like a dog. A dog, let's say, has a fur. And what kind of fur? Yeah, let's a fur with the ID 50. And the cat also has a fur, but a little different fur, so it's the ID 52. And it has a dog has 4 legs, 21. We store this ID with the select list 21. And a cat also has 4 legs, but thinner and shorter, so it's more 19. So if you store this sequence of numbers into the database, it's called vectors. What's all the fuss about it? So here's the thing. If you have a police sketch artist, this is what these guys are doing, right? They're working with templates. They're saying the hairline is this template 13, and the forehead is 33, and the eyebrows, and the eyes, the nose, the lips, the chin. So they have different templates. And if you, and this guy is not describing the templates. Like we all know our application IDs, right? You, yeah, it's true. Nobody knows the names anymore, but we all know our application ID. And this guy knows all the ideas of his template. So if I tell him a bunch of IDs, he knows exactly how the person looks like. So he can recreate and reproduce the visual of a person through IDs. And we all know the matrix. So this is exactly what Cypher did. He's looking at the matrix encoded, and he doesn't see the matrix anymore. He doesn't see the code. It's the same thing. And you say, maybe, wait a minute, we already had that calculating text into numbers, right? This was called hashes. Yeah, true, but these are not vectors because if you have a different hash algorithm, you get a completely different number. It has nothing to do with the word. In contrary, with the vector. So if you use a different vector model, you get exactly, not maybe quite the exact same number, but a very close number you get with the other vector model. So that's the huge difference. And this is the most important sentence of this whole presentation. Vectors preserve meaning or semantic. Remember the sketch artist? Once you have the numbers, you can reproduce the real thing based on the numbers. You can reproduce the face of this person. So you can reproduce everything you vectorize back into the real thing, which you can if you use hash. And that's the most important thing about AI and about this presentation. And you can vectorize everything, not just text. So you can vectorize images, you can vectorize videos, you can vectorize movements for robots, for example, speech, everything. Everything can be vectorized. So like medical history, code can be vectorized, housing data, and the whole internet can be vectorized. And it's easy to zip. So you can basically sit the whole internet into 100 gigabytes of vectors. So what is a vector itself? Well, it's a point in a dimensional space. And what can we do with vectors? Yeah, we can measure the distance between 2 points, right? It's a complicated formula, but it works. So we can calculate how close is one vector, 1 point to the other one. How does it look like? If you do this, if you vectorize words, you will end up with something like that. And this is just two dimensions, x, y, dimension one, dimension two, right? And you will figure out, wait a minute, all the animals are in the same space. Interesting. And all the fruits are in the same space. And within the same space, the berries are even closer. And the states are in the same space, right? So this means if I have the vector of a cat, the next thing, closest thing maybe is a lion. So it's similar, it's close. That's very important to understand that these things which are similar are actually close to each other. But we don't have just 2 dimensions. Regular vector dimensions are 1,000, 2,000, or 3,000 vectors right now, which means for this, remember the SketchUp artist, for his eyes or for his eyebrows, we don't have just 3, 4 attributes. We have 3,000 attributes for just for the eyebrows, which means you will get a this is how it maybe could imagine how a vector in a multi-dimensional space would look like. And if you have this high amount, which is called dimensions, the number of numbers inside the vector is called dimensions. If you have 3,000 dimensions of one object, of one thing, the eyebrow, you can describe this thing very exactly and reproduce this thing very exactly. All right, what is a large language model, LLM? So we know, okay, we can vectorize everything. We learned we can vectorize the whole internet, which is just text, videos, pictures, and sound and whatnot, and store it into a zip file. So what are we going to do? The next thing is they invented something like a neural network, which is pretty similar to our brain. And then they load 30,000 foot view. Then they load the vectors, the zip vectors from the internet into the brain, right? And then this thing, this neural network suddenly knows the internet. And if you download what you have loaded up, it looks like that. It's just a CSV file, right? There are the vectors and layers and parameters and stuff like that. But all you have loaded there are simply numbers, vectors. It's just a CSV file, which you uploaded in this neural network if you download it. Another important term is token, because you will hear this all the time. Tokens, how many tokens does it have? It's the measurement how much you pay for something. It's the dollar. How much does it cost? How much does a request cost? So what is a token? So we already know how to categorize a dog, right? With the fur, with the legs, and with the tail and whatnot. So let's assume a lot of dimensions, so you can categorize a dog very, very close. But this is not how it works. You, the model, the language model, is not categorizing the whole world, the whole word, which we would understand, but it categorizes or vectorizes just something like syllables. It's pretty close to similar to syllables, but it's not syllables. Parts of the word. And you can also vectorize parts of a word. You can vectorize a B. You can vectorize a four. So this said, AI predicts the next syllable, the next token, not the next word, just the part of the word. So if I ask a large language model, what should I do to upgrade my system? What does it do? It would say, be the next, next closest, the next closest token to be in our vector space. Remember the elephants and the tiger and the lion. The closest token next to B is 4. So he just returns 4. He does, and then he said, oh, the next closest vector to the question and the answer B4 is U. And the next closest token to that is up. The next closest vector token is take, grade, uh, back, back, up. What did you do? You did the exact same thing in your brain. You watch, I know the next closest thing to back up. Here it is, back up. So we're working exactly the same. 30,000 foot, yes. But yeah, we can discuss this on the party then. Um, but this means AI doesn't understand a single word what you're asking. It doesn't understand a single word what it's answering. It doesn't understand a single pixel what it's creating. It doesn't understand anything. It just predicts the next likely pixel, the next likely token. Not pixel, a token is also a vectorized thing. But it makes it can it's amazing what it can create, but it doesn't understand what it does. Very important to know. But this means it also can make mistakes, which it does, and it's called hallucination. So we are the same, Bartosz. We all said once, oh, take the next left. No, 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 I mean right. If we can ever misspeak anything, meaning we're just talking without validation. We don't even know what we say. We just talk without an instant that is thinking about every word I say. This is not working. We just talk without realizing, and then we can make mistakes, right? So we are very similar, Bartosz. So the next thing, if we ask a question, the question itself is vectorized. We can vectorize everything. We can vectorize the whole question and send it to the large language model. And then, like we said, before you upgrade, blah, 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 take a backup. So it generates something. It generates content. In this case, text. It can also generate music, images, movies, movements, right? And if it generates something based on our question, it's simply called Gen AI, generative AI, just to explain this term. I want to distinguish this generative AI and hallucination thing with a different approach, what we did at my customer side. Um, so a rule-based approach and not a predictive approach. So what can you do? Oh, you have your neural network. You load the product manual in this neural network and not the whole internet, right? And then what you have is, or what you want to create is a rule-based chatbot. And how do you do that? Oh, you get the top 100 customer questions, right? There is this poor lady answering all day the same questions from customers. Okay? And just take them, vectorize them, easy. And then you have this fixed output, the expert answer. This poor lady who knows exactly how to answer, and she's doing this 100 times every day. And then you have a real customer question, which is not exactly the same customer A asked, but similar. And this lady recognized, yeah, he means the same thing. And this is what we can do now with the similarity search. We can say, okay, find the closest general question we have vectorized, and then return a fixed deterministic answer. So then you can be sure nothing will be nothing will be hallucinated from the model. He will always get this certain answer. It could be that the question was not close enough. That could be wrong, but you can then take this question and put it into your baseline, right? Just to give you an understanding. There's a different approach. You don't have to rely always on generative AI. You can make a rule-based chatbot. It's a lot. Okay. It was the beginning. Next, what are tools? And then I show you how we implemented it in apex.world. So we learned that a large language model is just a vectorized internet in its brain. Problem, it has an expiration date. So once you load this vector into the LLM, this is it. It doesn't learn anything after that. If you ask a question after this specific date, it doesn't know anything about it, or it hallucinates. Right? Yeah, that's too bad. But if we are using ChatGPT, which is just a program environment, it's an application framework, I would say, which which uses an LLM, but it has a lot of other things around it. For example, it has a calculator. So ChatGPT, the interface, the website, gives their LLMs a calculator. So if the LLM needs to calculate something, it doesn't have to find the result in the internet, in his brain. It simply can use the calculator. And he can even write a program. He can use a tool, a programming tool, to write a program to get the answer, and then that he can give you the right answer. Or it can search the internet, which because he just doesn't know what happened recently, but he can search the internet to get this additional information. Or it can upload files, or you upload files. Right? Or you can, and which is called RAG, which we will get into detail in a minute. And it can even ask your database about additional content. And what is this thing? So all these things is called context. I don't know the answer myself in my SIP internet, but I need more information. I need a calculator. I need to search the internet. Like this is exactly what we would do. Bartosz, we are pretty similar. So we would use a calculator, right? If it's a complicated calculation, we would look up the internet, or we would or look into our database, right, with an Apex application and get the answer. And we would do the exact same thing. So if it doesn't know the answer by itself, it uses so-called tools to get additional information, which is called context, to be able to answer your question. All right, let's look into this RAG thing. The apex.world AI assistant. In our new version, we have built an AI assistant with great people. So these are the people. It's Matthias. He's the only other UX designer I know. And me, and I'm the founder and the admin. And then we have Maxime, and he's a great service, askmax.solution. So you can ask him anything. He knows everything about everything. He's crazy. Really, I worked for him since day one, and he was never able to not solve a problem, an Apex problem for me in minutes. And you probably know if you're on Slack, you know him. And then we have Philip. Philip is crazy. He also knows everything and can do everything. And then he wrote the crawler, and he's even faster than Maxime, and Maxime is crazy fast. Philip is Max Verstappen. And then we have Wolf, and he's our AI freak. He's our AI professor. So if you want to know anything about our implementation, talk to me and I hook you up with the right people. So what is RAG? RAG is called Retrieval Augmented Generation. And all we focus is on the retrieval part because this is all we can do. Because augmented means give me more context. This is what augmented, give me more. Enhance my knowledge with more, with context. And generation is what the model is doing. So we don't do anything. So all we are responsible for is the retrieval part. And what AI is basically, or what the RAG is all about is tell me your name and I know how to call you. So give me the answer. This is what AI wants from you, what the LLM wants from you. It wants the answer. And if you say, well, if I would know the answer, I wouldn't ask you. Then it would say, well, can you give me at least a paragraph where I can find the answer? I said, well, I could read the paragraph myself. And it would say, can you give me at least a PDF document where I can find the answer? Yeah, okay, maybe that's a deal, right? I give you the PDF document and you find the answer for me. So this said, the less information, the less pollution you give the LLM, the more likely you get the right answer. And the more context you give it, it's harder for him to find the right answer in this whole context. So how did we do that? So we crawl all the Apex documentation, and that's a lot, right? And Philip did this. And we have blogs for 10 years. Apex World is now 10 years old, and we have 2,000 fish more blogs. So we have all the blogs as context, and we have the office hour transcripts as context, and we have AOP manual as context. We have flows for Apex as context. So we could have a lot of context, additional information for the large language model. And what we're going to do with that, we don't give the AI the whole documentation, all 2,000 blocks. We don't do that. We don't. We at the beginning we just gave him one block at a time, but then we said, well, it's even too much because the vectorization works also very well for just a paragraph. So we decided, and this is what you do in general, you chunk the content in little chunks. And we decided, let's go with 500 words, and it worked fine. So you take the first 500 words of the blog post, the next 500 words of the blog post, and then we also send, if we find this middle part of the blog post, we also send the part before and after, but that's detail. So first of all, don't give it everything, but just a part of it. And what we're going to do with that? Yeah, we create vectors out of it. And vectors, there are models, vector models, but these are not large language models. They don't generate anything but vectors. You give him a text and it generates a vector out of the text, out of the of this 500 words. And you can store it in a vector database. Oracle has a vector database in 23 AI. But since we are on a free database, and we already said it, there's not much space. We use an open source, very nice vector database for free, Qdram. Works fine. Okay, now what we're going to do is, remember, we have all the chunks now from the documentation, from the blogs and the office hours, and everything is chunked, everything is vectorized in this vector space. What are we going to do now? A user asks a question. What we're going to do? We vectorize the question with the same vectorization model, with the same vectorization is called embedding for whatever reason. Same embedding model, and we get a vector back from the question. And then we take this vector from the question, go to the vector database and say, hey, give me the 15 closest vectors you find. This is what it's doing. So, hey, I give you the 15, I find the 15 closest vectors. And together with the vectors, we also store, of course, the ID of the chunk we have in our database. So what we really get back is not 15 vectors, because we can use vectors, but we get the IDs of the chunks back. And then it's easy. Then we are back in business, right? We have primary keys. We go to the database and get the chunks back, the 15 chunks back. And what are we going to do now? Is, oh, this is the animation for it. So give me back the 15 chunks. Here it is, 15 chunks. This is what you also get in the AI assistant. And we also show you the distance. How close was this chunk to the question, right? And then we send these 15 chunks together with the context to a real large language model, which is now 4.0 for now. And then it answers. That's all about RAG. I know it's fast, but stay with me. It's we have something to cover. So our system prompt says, don't use your internal knowledge. Don't use your internet knowledge. Just use the context we provide you. So it's much less likely that it hallucinates. Future enhancements we're planning is instead of using vectors, we can also use good old Oracle text. And we can say, give us the 15 chunks with the most relevant text keywords, Oracle text search keywords. So we get chunks back, right? And the benefit is we don't need vectors, we don't need a vector database, and we can combine the two approaches with um, Oracle text and vector search. We can use five chunks from vector search and 5 chunks from Oracle text and see if we get a better context. The next thing we can think about is a so-called graph RAG. So some of you probably know graph. So we see that this guy, Tolkien, he was born in South Africa and died in the United Kingdom. But we know countries are in a different vector space than a person. So we would never get through a vector search countries when I'm asking for Tolkien. I would get other people like Orlando Bloom is another person. It's close. Person is close. But person and country is not close. So what is this approach GraphRag doing? So you can do a vector search to find this initial node called this Tolkien guy. And then we can use the graph capability to traverse to the closest nodes. And then we would actually get South Africa and United Kingdom back into the context, which we wouldn't get just with vector search. Right? And then we can combine this with Oracle text. So just to give you a feeling, it's all about getting the most relevant content. How we get it, nobody cares. You can do it by hand, which you do if you upload it by yourself with a file. Okay, let's see how we get context through the database. So here we have our AI schema for apex.world. So we can have something like an API, a REC API, and there we get the answer. This is what we could do. So let me show it how it works. This is a German demo. I don't have the original application anymore. So here are the translations first. We have two tables, palettes and article. And the function, and we only call functions. We are not giving AI direct access to our tables. We just give AI access to our functions. So question 1 will be, how many red articles do we have? Question 2 will be, on which palettes are they? So here it goes. So it's Apex application, as you all recognize probably. So how many red articles have we? And it said, oh, 28 red toy cars and 17 unicorns, and together 45 red articles. Where are they? Oh, they are on these palettes. Easy. How is it working? So the user is asking this question. Can do this. Asking this question, and then AI doesn't know. I don't know how many articles do you have, but I gave the AI a function, and I described the function. I said, hey, you get a function from me. It's called get article list. I said, oh, interesting. I can call that, get information back, context back, and maybe I can answer your question then. And this is exactly what it's doing. So this is the tool, get article list. This is what it gets back to the AI. Then it's called the palette query, and this is the information he gets back, and then he can actually answer the question. So context through database API. And this is how it looks like if you publish a function, a tool to the AI. You just describe it as a JSON object. What does it do? What parameters do you have to call? to get the right answer. And then the AI knows, I don't know it by myself, but I have these functions and I can call the database to give me the right answer. Next thing, create me a pie chart of articles on pallets. So this is interesting now because um, AI will now generate a pie chart based on a database query of result. And this chart was not coded in Apex. This is not existing. It's just an HTML region, right? It just shows what the AI gives back, and it gives back a chart. Fine. We show the chart to the user. So you don't have to code this. And now your users can additionally use your Apex application and can get additional content, reports, numbers, and whatnot, and charts without you ever coding it. Next slide. Can you reserve the red toy elephants? So yeah, we give it a function to reserve a toy, an article. So, and what does it do? It calls, now it calls a modal dialog. AI is calling the Apex application back, opens a modal dialog, and let me confirm, yes, I want to reserve this. And if I hit OK, it actually updates the database through a function. So AI can also operate your Apex application. All right. But at the end, we don't need, maybe you already realize that we don't need an UI anymore, right? So my friend John Dixon showed this in another presentation. You can just use Teams as an interface, which is already there. And you can ask the same question um, to the LLM and use as an interface just Teams. And you can also get notified from the database to Teams if something is happening, if alert is happening. So just to give you a basic understanding how you can use AI. Okay, last section. What are agents? So Sunil wrote me a message 2 days ago. Say, hey, I'm coming to Apex, Alpe, Adria. You would like to have dinner together? I said, yeah, sure. Um, um, so my thinking was, okay, what now I have, if I don't have a secretary, or I would have a secretary, I would say, okay, can you check all the locations, the best steakhouses, and make it a nice experience? So check the agenda of this conference, and check when does the conference end, and then reserve a table from the best steakhouses here in Zagreb. Um, 20 minutes after the end of the conference, which I don't know when it is, which I didn't know at the time, and order a limousine. Call me when the driver has arrived. It won't be a limousine, sorry, Sunil. We will take a taxi. And then yeah, and then send me a confirmation email and send a Teams message because Sunil is working with Teams of the restaurants. We get the reservation and also send the menu of the reservation and stuff like that, right? And also, oh yeah, by the way, check my database. I have some AOP questions that I can talk with him about, which we won't, Sunil, no worry. But this would be a regular task. So, and this is what AI needs to do. It needs to have another APIs like connection to mail, API to Teams, to OpenTable, to Telecom, to call somebody, and to check my database for the latest AOP questions. And this is how agents look like. It's our workflows. Do this, and if this is happening, do that, do that, do this. So this is how regular agent workflows look like. It can be very, very complex, right? And what we call APIs to get additional context and more information to answer and to decide which way to go after that, they call it integrations. The more tools you integrate, the more services you integrate, the more powerful your agents can be. Yeah, and so Woody is already scared about all the integrations. Why? Because he understands the consequences. This will be the new employee in the future. Agents, not us. And that's already a fact because OpenAI already offering you agents for you for 2,000 to up to $20,000 a month doing the work. That's real. And so what is an agent? Agent basically is an API called integrations in this area, plus workflow. What is happening if this guy is not answering? Okay, then call another restaurant, right? Plus a scheduler jobs. Do it on a regular basis. Just do it every Monday in the morning. Right? This is what agents are. So what I did, this is the latest and greatest AI agent framework, which you don't have to code with complex workflows, but you can do it by yourself. Or it generates the workflow by itself. It's called GenSpark. And I said something similar. So I'm in the Apex conference here in Zagreb on this Friday, and please check when it finishes and give me a recommendation about the best steakhouses. Okay, this is real time now, not doing anything. This is real time. I said, okay, let me check it out. Okay, let me first check this Apex Alpe Adria. Okay, let me check the schedule. This is the thinking process, right? And I said, okay, let me find the agenda. Okay, get me the answer back. Okay. And then it comes up and say, okay, this conference is happening at this hotel in Zagreb and it ends at this time, which is wrong. It hallucinates. It says it ends at 4 p.m., right? It hallucinates. 4 p.m. was a break, or will be a break, but it's not the end of the conference. So hallucination, always check for that. But still, and I said, okay, let's assume it's 4 p.m. And now find me the best steakhouses here in Zagreb. Okay, let me figure it out. And also I said, please give me directions to the steakhouses and recommendations. So now he finds the steakhouses. Where are they located? Real time. I don't do anything. Um, and see, okay, this is the marble is the next one. Okay, let me find out where this is. This is located over here. The next one, the next restaurant. So it gives me five-ish options, great options. And now he calculates the directions from the hotel. I'm not doing anything. And he says, hey, here are the pictures. Oh, the second. I like the second one. This is where we're going, Sunil. And so another one. This is the hotel restaurant. Another one. And then he says, okay, here are my recommendation. Right? So another one. This is it. At the end, it said something like, hey, you can stay in the hotel and it has a convenience factor because you don't have to travel, right? You're already there. And this is the menu and this is the benefits of it for it. And and this is where we're going. Why? Because they have cattle fed with Belgium chocolate. Dimitri used to fed me with Belgium chocolate and it's still there, right? And I cannot afford it anymore. So the second best thing is cattle fed with Belgium chocolate. And just imagine you have a secretary and you give the task to the secretary, and she will take 2 days to gather all the information and create these beautiful reports, all the pictures, group them together in a PDF and send it to you. It will take her 2 days. And this took 2 minutes. This is why agents are real in the workforce. Okay, what have we learned? Vectors store meaning in numbers. Very, very important to understand. So once you get the numbers back and you get the real thing back. Remember the sketch artist. The next thing, a large language model only knows the trained data. So when it was trained and after that it doesn't know anything and it doesn't learn additional stuff. It stays in this state. So to to have more capabilities than its internal knowledge, LLM, the large language model, needs tools, also called APIs, or in the context of agents, it's called integrations for more information, which is called context. And agents are nothing more but APIs, so-called integrations, plus a workflow. You design the workflow and the scheduler job, when should it run and on a regular basis. Let me end with two terms. So what is AGI, artificial general intelligence? May have heard that before. This is when AI becomes as smart as the smartest human in his field, in his subject. So smarter than the smartest chess player. We already have that. Smartest than the smartest physician. Smartest than the smartest programmer. We already have that. Smartest than blah, 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 in all different modalities, in different areas. If we have reached that, it's called AGI. It's more like, my feeling is we are already there. But there's a political thing with OpenAI and Microsoft. If they call it AGI, Microsoft is out and blah, blah, blah. So, but either we are already there or we are very, very close. And we definitely hit it this year. And the next thing is called artificial superintelligence. What happens after that? AI takes over. It doesn't need us anymore. That's a real thing. Right now, it programs in English with words. It's it's not efficient at all. AI will code in future in symbols like the matrix. We don't understand anything with what AI will do. It will be smarter than every human being on the planet, and it improving itself. And well, we will all see where this is ending up. Either we will still be there in 2 years or not. So yeah. So like I said before, everybody who is here, plus send me an email with the subject AAA Apex 25, and you get a 1 year free access to apex.world AI assistant. Just shoot me an email, and yeah. And like I said, I have stickers still here. If you want them, let me know. Any questions? I'm pretty close. I just more than, and it was 100 slides. So thank you.